Hello everyone, welcome to my channel Computer Classes by Rachna. Today we are going to discuss what are AVL trees. If you have not seen my previous videos, please go back and watch them for binary trees and types of trees, which includes AVL and its rotations. Today we are going to discuss RL rotation with example. As you can see, the given tree is a balanced binary search tree, which is an AVL tree. In this AVL tree, all the nodes have the balance factor, which is equal to 0, 1 or minus 1. What is a balance factor? The height of left subtree minus height of right subtree. For example, 20 has the left subtree height as 2 and the right subtree height as 3. The height can be taken as the number of path in the longest branch. So we have the 20 to 30, then 30 to 40 and 40 to 35. The length is 3. Or we can take 20 to 30, 30 to 40 and 40 to 45. The length is again 3. So 2 minus 3 is minus 1. Balance factor of 20 is minus 1. Balance factor of 30 is 1 minus 2, and which is minus 1. Balance factor of 40 is 1 minus 1. The balance factor for 10 is 1 minus 0. And the leaf nodes have balance factor as 0 because the left and right subtrees have height 0. 0 minus 0 is 0. The leaf node means the nodes which do not have the left or right subtree. Alright. So now what we have to do, we have to take an example of RL rotation. For RL rotation, we have to apply a rotation in which we add a number, let's say 34. So where will we add 34 first of all? Since 34 is greater than 20, it will be added to the right of 20. Now we have 30. 34 will be added to the right of 30. 34 will be added to the left of 40. 34 will be added to the left of 35. Now when we add this, now 34 will be added to the left of 35. What we have here? Now let's see the balance factor. The balance factor of 34 is 0. The balance factor of 35 is 1 minus 0, 1. The balance factor of 45 is 0. The balance factor of 40 is 2 minus 1, which is 0. The balance factor of 30 is 1 minus 3. The length of the longest branch is 3 here. So 1 minus 3, which is minus 2. The balance factor of 20 is also 2 minus 4. But since 30 got the unbalanced factor here first because 34 was added, so 30 is considered to be alpha. Now let's check what kind of rotation is this. Since 34 is added to the right child's left subtree of alpha, since 40 is the right child of alpha, which is 30, and 34 is added to the left subtree of 40. 40 is the right child. So when a node is added to the left subtree of the right child of alpha, this becomes RL rotation. RL rotation. Alright. So when we have RL rotation, I have already discussed what is to be done in RL rotation. Let's read. In RL rotation, we rotate the right child to the right and we rotate alpha to the left. Since it is double rotation, we will perform rotation twice. We will rotate right child to the right and we will rotate alpha to the left. Moving back to our example, what we have to do? We have to rotate the right child, which is 40. We have to rotate the right child, which is 40, to the right. When we will rotate 40 to the right side, 35 will come up and 40 will go to the right subtree of 35. And 45 is at the right side of 40, it will remain as it is. So when we perform the first rotation, we perform moving the right child of alpha to the right. So 40 will move to right, 35 will come up in place of 40, and the 35 left will be 34. So after the first rotation is applied, moving 40 to right, we will get this. So see, 35 moved up, 40 was rotated to the right, and 34 was at the left of 35. Now we have to perform the second step. What is the second step? We have to rotate alpha to the left. What was alpha? 30. Now we rotate 30 to the left. When we rotate 30 to the left, what will happen? 30 will move to left and 35 will come up. Since 30 will move down, the right child of 30, 35 is going to come up. Now when 35 comes up, the left of 35 was 34. But now if 35 is going down, the 30 is also going to come to the left hand side of 35. So what will happen? Since this 30 is going to move to the left, this particular edge is going to come to the left of 35. So 34 will become the right of 30. Look here. After this rotation, 30 is rotated to the right, 35 comes up, and 34 was at right of 35. 34 was at right of 35. Now it becomes right of 30. So this has changed. 30 moved to the left, so 35 comes up and 30 comes to the left of 35, and the 34 which was at the left of 35 becomes the right of 30. Now you see it is again a balanced node, because the balance factor of every node is 0, 1 or -1. It is a balanced AVL tree after applying RL rotation. This is an example of RL rotation.